Hello there, and welcome to week 4. This is a huge week, and it's all about trigonometry. Section 5.1 is an introduction to angles, angles in standard position, coterminal angles, and very importantly, converting from radians to degrees and vice versa. In calculus, we do most things in radians. Let me just mention coterminal angles. The angle I have drawn here in this circle is negative pi over 4. But if we're solving an equation involving maybe sine and cosine, and we want all the angles theta between 0 and 2 pi, which is typically the interval that we want our solutions from, then a solution of negative pi over 4 wouldn't work because it's not in that interval. This is the angle negative pi over 4, because if it's a negative angle, you go clockwise. But negative pi over 4 is coterminal with the angle that starts at 0 and goes this way, and that is 7 pi over 4, and that is in the interval from 0 to 2 pi. So coterminal angles share the same position, but they're actually different angles. Section 5.2 is the longest section in this part 1, and it's all about the 6 trigonometric functions and their definitions. I strongly suggest you watch video 1, which is a lesson introducing the 6 trig functions. And so this clip here is right from that video. You can see that here we have a circle, and the circle has radius r, and this is the angle theta, and this line here intersects the circle at a point, x comma y. And the trig functions are defined in terms of x, y, and r. And these are the definitions below. For example, sine theta is y over r, and cosine theta is x over r. You can also define these trig functions in terms of opposite, adjacent, and hypotenuse. And that's actually covered in a separate section down here. Section 5.4 is all about right triangle trigonometry. Okay, the unit circle. You have a handout in this module called Unit Circle Practice, and you need to memorize. There's quite a bit to memorize this week in terms of trig. One thing you need to memorize is your unit circle, and the second thing is the other handout, which is in part 2. The part 2 module is a list of identities you need to know. There aren't a lot of identities that I'm going to have you memorize, but there's a few that you just can't get away without knowing. All right, so let me talk a little bit more about the unit circle. And the key to the unit circle is on the next page. So if you look at your unit circle, it's a blank unit circle that you're supposed to fill in, and you can print it out a bunch of times and just keep filling it in until you get it. But if you can memorize the reference triangles, it makes filling in the unit circle super easy. So there are 3 reference triangles, and I'd make them all with hypotenuse length 1, because a unit circle is a circle with radius 1. So any triangle on the unit circle is going to have hypotenuse 1. And so there are 3 angles, pi over 6, which is 30 degrees, pi over 3, which is 60 degrees. These are related. The opposite side on pi over 6 is the shorter side, and it's a half. Its length is a half. And the adjacent side is the longer side, and it's root 3 over 2. For pi over 3, those just flip. The opposite side is longer, root 3 over 2, and the adjacent side is the shorter. And for pi over 4, opposite and adjacent are equal. They are both 1 over root 2, or if you rationalize, that's the same as root 2 over 2. So this one is also root 2 over 2. So to fill in your unit circle, for example, here we have the angle pi over 6. So if I drop a perpendicular down to the x-axis, I get the reference triangle. I know its opposite side is the shorter side. That's the y-coordinate. So y is a half, and I know this adjacent side here is the longer, and so that has length root 3 over 2. And then if I come over here to 5 pi over 4, this is the angle, sorry, not 5 pi over 4, 5 pi over 6, this is the angle 5 pi over 6. The reference triangle is pi over 6. So in here, I have pi over 6. So the opposite side is a half. And the adjacent side is the longer side. It's root 3 over 2, but we're in quadrant 2. So this is negative root 3 over 2. So I know the coordinates here are negative root 3 over 2, comma, 1/2. So I can use some symmetry, and I don't have to memorize all these coordinates. I can just use logic as I'm going around the unit circle. Okay, part 2, more with trig. So there are some identities that I mentioned before. There's an identity handout, and then in this section, you're only going to look at the top 3 sets of identities: the Pythagorean, the quotient, and the reciprocal. So you need to memorize those identities. There are 3 Pythagorean identities that you need to memorize, but they can be the other 2 can be derived from the main one, which is cosine squared theta plus sine squared theta equals 1. Okay, I mentioned section 5.4, that's right triangle trigonometry. Now section 6.1 is the graphs of all the trig functions. And so just to make it simple, what you need to be able to do in 6.1 is you need to be able to graph sine, cosine, and tangent from memory. Just know what those look like. For example, sine looks like this. It goes through the origin. It goes up, down, up. This is 2 pi, and then it repeats. In addition to being able to graph those 3, you also need to be able to graph some translations of sine and cosine. So these 2 equations here change the amplitude, period, and phase shift, and you want to be able to graph simple translations of sine and cosine. The last video in this section is the negative angle identities. I call them even odd. So these right here are I call them even odd, but your book calls them the negative angle identities because they involve negative angles. And so you should know those 3 identities. Okay, it's a big week, but time investment now will pay off. If you have not done trig before, you're going to have to spend a lot of time on this week, the unit circle and the trig identities, and it's going to be tough, but it will pay off in the next week. If you've done trig before, then it should be a little bit easier for you. Okay, and that's it, and you can get started.